Hey, today I will be going over the lesson of roots and radicals. So in this section, we introduce a new category of expressions and functions that contain roots. For example, the reverse operation of squaring a number is finding the square root of the number. So this is a square root sign. You have the square root symbol that we use. The symbol is called a radical sign. The number under the radical sign is called the radicand, and together we refer to the radical sign and its radicand as the radical expression. So, just to reiterate those new vocabulary words, you have your radical, which is this symbol right here. You have the radicand, which is the number under here under the radical. And you have the radical expression, which is the whole thing. Another word you may want to put in there is index. Index, there's usually a little number in front of the radical sign. If it's a square root, there's not. It's just implied that there's a 2 there. But anything other than a 2, you'd have to show that's there. And so any of these little numbers is called an index. Make sure you get that word too. We are able to solve radicals by doing the opposite operation. So we know that the cube root of 8 equals 2 because 2 to the third power equals 8. So, as I've already drawn, when you take the cube root of both sides, you get the cube root of 2 cubed is 2, and that makes the cube root of 8 2. With the next one, the cube root of negative 8 is negative 2. That would be because negative 2 cubed equals 8. So negative 2 times negative 2 times negative 2 gives you negative 8. For the fourth root of 81 equals 3, because 3 to the fourth power equals 81. So you have 3 times 3 times 3 times 3 gives you 81. Therefore, the fourth root of 81 gives you 3. When you have the negative in front of the radical, you would solve it the exact same way, except it makes your answer negative. So you do the fourth root of 81, you still get 3, but because it was negative, it makes your 3 negative. Now, if the negative is under the radical, it gets a little tricky. For now, until we get to it, any square root of a negative number is not real. You cannot have the square root of a negative number. A few examples. We have the square root of negative 16. You know that the square root of 16 is 4, but the square root of negative 16 is not possible because there's not two numbers, two of the same number you can multiply together to get negative 16. It would require a negative 4 and a positive 4. So if you tried 4 and 4, you'd get positive 16. If you tried negative 4 and negative 4, you'd still get positive 16. There's no two of the same number you can multiply together to get negative 16. Therefore, the solution is not real. For B, you have the square root of 44 plus 25. When your radicand looks like this and your answers are under the radical, you would do this operation first. Excuse me. So you do 144 plus 25 and then get the square root of 69, which equals 13. That is actually completely different than having the square root of 44 plus the square root of 25. In this case, you do not do the addition first. You do what's under the radical first. And you get the square root of 144 is 12 and the square root of 25 is 5. 12 plus 5 is 17. And 17 and 13 are not equal. Therefore, they're not the same expression. So when you're finding roots, you can just say that for any number a, the square root of a squared equals a. That's because the square root and the square, they cancel each other out. So it just equals a. They're inverse or reciprocal operations. So we're going to try a few examples. Okay, we will do the square root of 45p squared. First, what you want to do is do a factor tree. And a factor tree, what it does is it breaks down all the factors until you have all the factors broken down into completely prime numbers. So we call this our prime factorization. Okay? The prime factorization is simply when all the factors are broken down into prime numbers. So to get 45, we could do 5 times 9. 5 is a prime number, so when we hit a prime number, we underline it. 9 is not a prime number, so we're going to break that down to 3 and 3. Those are also prime numbers. Once I have completely all prime numbers, I have my prime factorization. So this is equal to the square root of 3 times 3 times 5. We also cannot forget our p squared up here. P squared is simply p times p. So this is our prime factorization of 45p squared. And the way we simplify this is a square root means that it takes 2 of a number in order for it to come out. So, for example, we have 2 3's here. So when we take the square root, we have those 2 3's. One of them can come to the outside of, can come to the outside of the square root. Same goes for one of the p's. We have 2 p's, so because we have them under a square root, we can bring that out. So then we're left with 3p square root of 5. It's kind of like when you take the square root of 9, for example. So you have the square root of 9. We already know that equals 3, just from knowing square roots. But if we were to break it down to show you the example, we know that 9 breaks down to 3 and 3. Those are prime numbers. So when I write out the prime factorization, I get 3 times 3. They both come out, and I'm left with simply just 3. So that's why this works. When you do a square root requires 2 of those numbers in order for it to come and be outside of the radical. We'll do a few more to practice. For b, we have the square root of 200 m to the 4th n. Now remember, we want to get the prime factorization. We just focus on the number for right now. So 200 can be broken up into 20 and 10. 20 times 10 equals 200. Neither of these are prime numbers, so I have to continue to break them down. 10 can be broken down into 5 and 2. These are both prime numbers, so I underline them. For 20, we can break 20 down to 4 and 5. I got another prime number, so I underline it. And then 4 can go to 2 and 2. As you can see, it's kind of starting to look like an upside down tree, so that's why it's called a factor tree. But it gets our prime factorization. Now that we have all prime numbers, there's nothing else to break down, we can write out our prime factorization. We get 2 times 2 times 2 times 5 times 5. We have a 2, a 2, a 2, and then a 5 and a 5. So that's our prime factorization for 200. You're always welcome to check this in the calculator if you'd like. You can always make sure that 2 times 2 times 2 times 5 times 5 does, in fact, equal 200, if you're ever unsure. And now we just have to break down our variables. It says m to the 4th. M to the 4th simply means m times m times m times m. We have 4 m's, and then 1 n on the end. Some of these prime factorizations I know can get very long, but once we simplify them, they get a lot shorter. So we have a square root, which means anytime there's a square root, there's an imaginary 2 here. We never have to write it. It's just known to be there. But it just means that's how many numbers it takes in order for them to get out. So we have two 2's here, which means a 2 can come out. We have two 5's here, so a 5 can come out. Excuse me, I ran out of room, so I have to write it a little bit diagonal. We have two M's here, so an M can come out. We have two M's here, which means another M can come out. Okay, so we're left with 2 times 5 times M times M. And what's left under the radical is we have a 2 that didn't get used, and we have an N that didn't get used. When we simplify this, 2 times 5 is 10. M times M is M squared, and then 2N. So make sure you multiply everything that's on the inside and everything on the outside to put it in simplest form. Okay? Okay. Next I'll do C. Notice this time there's a number that's already on the outside. So we have 6 square roots of 72 x squared. Let me change markers. Okay. So we actually leave the 6 on the outside and still continue to do the same process. We're going to break down our 72, which is 8 times 9. Notice we don't have any prime numbers, so we can break it down some more. 9 breaks down to 3 and 3. Those are both prime numbers. 8 breaks down to 2 and 4. 2 is a prime number, but 4 is not. You have to know your prime numbers in order to get this. 4 breaks down to 2 and 2, which are both prime numbers. So when I write out my prime factorization, I get the square root of 2 times 2 times 2 times 3 times 3. Okay? I have 3 2's and 2 3's. And then I just have to do, oh, there's a 6 there. Alright, right here. And then we have x squared, which just means we have a times x for x squared. Remember, we have a little imaginary 2 right there for the square root. So that means it takes two numbers to get out. So we have two 2's here, which can come out. We have two 3's, can come out. And we have two x's, one can come out. Right? So when I rewrite this, I get 3 times 2 times 6 times x. And the only thing left under the square root is the 2. When I simplify what's on the outside, we get 3 times 2 is 6, and 6 times 6 is 36. So we actually have 36x squared root of 2. That's your final answer. And for the last one, we have 2 square roots of 8p squared q cubed r. The only number in here to break down is 8. 8 is 4 times 2. 2 is a prime number. We underline it. And 4 breaks down to 2 and 2. Those are also prime numbers. So we got our prime factorization this time. We have 2 on the outside. It's already there. Times the square root of 2 times 2 times 2. That takes care of our 8. 2 times 2 times 2 is 8. We have times p for p squared. Times q times q times q for q cubed. Times r. Like I said, these can get pretty long. Okay, this is a square root, so we have our 2 that's in front of here. We don't show it, but it's for any other ones we would, but for square root we don't write the 2. Which means it takes 2 2's, bring one out. I have 2 p's, There has to be 2 in order for it to come out, or it will not work. So you have P, run out of room. You have 2 Q's, and there's no more doubles. So when I rewrite it, I get 2 times 2 times P times Q, and everything left on the radical. I have a 2, Q, and an R left. And when I rewrite it, 2 times 2 is 4, so I get 4 PQ square root of 2 QR. And that's how you simplify those. So now we're getting into cube roots. So when we have a cube root, there. So a cube root is when there's a little 3 in front of our radical. Okay? It just means it's a cube root. So the cube root of A equals B means that B cubed equals A. Say, does that make sense? The cube root of A, if the cube root of A equals B, then B cubed equals A. Because remember, they're opposite operations. So just like before, we had the square root of A squared equals A. The cube root of A cubed also equals A, because you have a cube root and it's to a 3rd power, so they can cancel each other out. Oh, one more. So for an example, we have the cube root of negative 125. So what it's saying is, what to the 3rd power equals negative 125? Well, if we do negative 5 times negative 5 times negative 5, that would give us negative 125. So this would be negative 5 to the 3rd power equals negative 125. Because when you do a negative times a negative, that's a positive, but when you times it by another negative, it makes it negative again. So you can actually check it in your calculator and make sure that negative 5 cubed is negative 125, but that makes it the cube root. So notice that square roots, you cannot take the negative of a square root because no 2 numbers will give you a negative number, or no 2 of the same number will give you a negative number, but with cube roots you can. So if you have a cube root of a negative number, you can do that, because 3 negative numbers still gives you, or 3 negative numbers multiplied together still give you a negative number. So we'll practice a few of these. Remember when I told you that 2, the little number, came into play? You have the index of 3 here. So you always write it if it's not a 2. Always have to write it. So we have A cubed, B cubed. Okay? So if we were to write out the prime factorization of this, we would get A times A times A times B times B times B. Okay? Sorry, I write a little crooked there. But because it's a cube root, remember our 2 that was out there that we don't write, but the 2 means it takes 2 numbers in order to get out from under the radical. Because it's a cube root now it's going to take 3. So here we have 3 A's. Remember, this little number, the index, lets you know how many it requires under the radical in order for it to come outside of the radical. But we only bring one of them out, so it's just A. And then we have 3 B's. But it just brings out 1 B. So the cube root of A cubed, B cubed actually equals AB. Okay? Let's look at B. We have the cube root of x to the 4th, y to the 5th. When we write out the prime factorization, we get x times x times x times x for x to the fourth, and then times y times y times y times y times y for y to the fifth. Okay? Notice we have the cube root, which means it requires 3 in order to come out from under the radical, but we only bring one out at a time. So these 3 x's will have 1x. These 3 y's give 1 y. Alright, there's no more. I don't have 3 of anything else, so I'm done. Which means I'm left with, I'm going to write it as xy times the cube root of, I have an x left, and I have 2 y's left, which is the same as y squared. So I'm left with x times y times the cube root of x times y squared. Okay? Now we'll try it with numbers. So for C, make sure you're getting all this in your notes. You have 3, or the cube root, sorry, the cube root of 27 a to the fourth. So when I break down 27, I get 9 times 3. 3 is a prime number, so I'm going to underline it. And 9 breaks down to 3 times 3. Okay? So when I write my prime factorization, I have 3 times 3 times 3. And then I have a to the fourth, so times a times a times a times a. That's my prime factorization. It's a cube root, which means it's going to require 3 of a number or a variable in order to bring it out from under the radical. Here we have 3 3's, so a 3 can come out. And we have 3 a's, so an a can come out, which means we are left with 3a, the cube root of a. That's our answer. Okay. And for the last one, I'll put it on the side. Okay. We have the cube root of 200m to the fifth times n. Okay, so we break down 200. We get 20 times 10. Neither of those are prime numbers. Here we get 4 times 5. 5 is a prime number. Underline it. Here we get 5 times 2. Both of these are prime numbers. And 4 breaks down to 2 and 2. Both prime numbers. So when I write the prime factorization, I get the square root of 2 times 2 times 2 times 5 times 5. Make sure you have all of your numbers. 2 times 2 times 2, 5 and 5. And then I have m to the fifth. So, hope I don't run out of room. M times m times m times m. Sorry guys. Times m times n. It's all under a radical, and I ran out of room there. But it's all under the radical. We have the cube root, so it's going to take 3 in order to get out. So you have 3 2's, and come out as 2. You have 3 m's, can come out as m. And I don't have 3 of anything else. I only have 2 5's, 2 m's, and 1 n. So when I rewrite it, I have 2m, the cube root of 5 times 5 times m times m times n, and when I simplify that, I get 2m, the cube root. 5 times 5 is 25. M times m is m squared, and n. That's my answer. Remember, for square roots, it only requires 2 to come out. If it's not a square root, it will have an index number, and whatever that index number is lets you know how many of each you need in order to bring it outside of the radical. Okay? So now we're looking at it with the roots of numbers other than 2 and 3. Notice we focused mostly on 2 and 3. But can we come up with an expression or something to let us know how we know if a negative can work? So remember how I said that the square root of negative 25 does not have an answer. So, oops, sorry, equal doesn't have an answer. But the square root of negative 27 did. The cube root. Sorry, cube root of negative 27 did. That was 3. Because we cannot have two numbers that multiply together to give us a negative number, two of the same number, but we can with 3, maybe we could come up with a pattern for this. So as you notice here in your slide, it has us consider the fifth root of negative 1. So if we have negative 1 times negative 1 times negative 1 5 times, a negative times a negative, oh, I'm sorry guys, 5 negative 1s. A negative times a negative gives you a positive. Well, a positive times a negative gives you a negative. A negative times a negative gives you a positive, and a positive times one more negative gives you a negative. So let's just go with negative 1 to the fifth equals negative 1. That lets us know that a fifth root, a negative fifth root, can be solved. Well, now has us consider with 8. If you have 8 negative 1s, what does that equal? So, negative 1, negative 1. This one's positive. And then you times it by another negative 1. That makes it negative. Another negative 1 makes it positive. Notice it's a pattern until we have 8. 1, 2, 3, 4, 5, 6. Sorry, I'm going sideways now. Negative 1 makes it negative, and one more negative 1 makes it positive. So when we have 8 negative 1s, we end up being positive. Does that mean, so if we take the 8th root of negative 1, that won't work because it requires a positive number. So as you can see, I want you guys to make sure you have this and make sure you highlight it, make sure you write it a couple of times, you really get it. An odd root of a negative real number is always negative. You see that? An odd root of a negative real number is always negative. So if we take the odd root, which means it can be the cube root, the fifth root, the seventh root, the ninth root, any odd number, your odd numbers. So an odd root of a negative real number is always negative. It's going to give me a negative number. Now check out just a little bit below it. An even root of a negative number is always a non-real number. So this is going to be our square root, our fourth root, our sixth root, our eighth root. Anything that is an even root of a negative number will be non-real number. So if I give you the fourth root of a negative number, let's just say, for example, the fourth root of negative 124, you don't even have to do any math. As soon as you see that it's a negative number under here, it's a negative radicand, and you have a even index, you know that this is not possible. You cannot have that. So pay attention. If this number, if your index is even, and what's under your radical is negative, it is not possible. Okay? Make sure you have that down. Make sure you also have these two sentences highlighted, underlined, starred, whatever you need. Okay? So now we have this little word problem. And it says, police use the function f of x equals the square root of 20x to estimate the speed of a car. f of x in miles per hour based on the length x in feet of its skid marks upon sun braking on a dry asphalt road. Use the function to solve this following problem. So what it's letting us know is this equation here, f of x equals the square root of 20 of x, is how police are able to tell how fast the person was going based on how long their skid marks are. So if x is the skid marks, f of x lets them know how far they were. So for the example, a motorist is involved in an accident. A police officer measures the car skid marks to be 45 feet long. So estimate the speed at which the motorist was traveling before braking. If the posted speed limit is 35 miles per hour and the motorist tells the officer he was not speeding, should the officer believe her? So how we're going to work this out? We have that f of x equals the square root of 20x. And now we know here that x represents the length of the skid marks. Well, it told us the skid marks were 45 feet, so we have that x equals 45. Okay? So all we have to do is plug it into the equation and see if the person was speeding or not, which means we just do the square root of 20 times 45. Okay, so that f of x equals that. And then when we simplify it, we get the square root of 20 times 45, 900. And when we take the square root of 900, we would have to do our tree. So I'm going to come over here. We have 900. That is 90 and 10. We have 9 and 10. 2 and 5. These are both prime. 9 is 3 and 3. Also prime. And 10 gives me 2 and 5. Prime. So our prime factorization for this, for 900, would be 2 times 2 times 3 times 3 times 5 times 5. So remember, if there's not a number there, you automatically assume it's a 2 for square root. Always. So we have 2 2's that come out. We have 2 3's, and 2 5's, which means we're left with nothing under the radical. Well, 2 times 3 is 6, and 6 times 5 is 30. So the square root of 900 equals 30. Now it says the speed limit is 35, and the motorcyclist says that he was not speeding. Should the officer believe her? Yes, because according to our equation, we have that the motorcycle was only going 30 miles per hour. The speed limit was 35, so the motorcycle was actually not speeding. And the last slide here explains how to work that again.